So it's May 14th, 2025. I think it's important. I've been really kind of bothered by this news that we've been hearing recently about thorium. Thorium as a fuel source for nuclear power plants. This is something that has been just been a fascination of various individuals over the last several decades. I'm talking all the way back to the 2000s. I can remember hearing people talk about thorium, and how great it is, and how it's going to give us all free electricity and everything. And it sounds like I'm going to be exaggerating, but the reality is that all I need to do is do a web search, and all I find are headlines saying things like thorium, world's greatest energy breakthrough, November of 2011. What if we had thorium-based nuclear reactors at home? At home. 1 year ago. Kirk Sorensen, thorium, an alternative nuclear fuel. Kirk Sorensen stumbled across thorium while doing research on how to power a lunar community. Okay, all right. That was in January of 2012. 13 years ago. The coming thorium energy something from 2024. PBS Space Time 2019. Thorium and the future of nuclear energy. 10 cool facts about thorium 8 months ago. It's something that is just, people's brains are just captivated by this element. Element number 90. Thorium. Atomic weight of 232 approximately. Grams per mole, right? The atomic show, number 185, is thorium superior to uranium? 2012. China's thorium survey finds endless energy source. Over here. China refuels thorium reactor without shutdown. China unveils first meltdown-proof thorium reactor. A thorium reactor has rewritten the rules of nuclear energy. You can see that you just don't find a negative headline on this stuff. China's thorium revolution, 60,000 years of energy. China just fired the first thorium reactor that can be reloaded while running. China's game-changing thorium find, 60,000 years of energy. These people are basically suggesting that this thorium is a substitute for crude oil. IEE spectrum. That's a pretty, should be a pretty down-to-earth technical source, right? Why is China building a thorium molten salt reactor? So, you might realize here that this is the reason I'm talking about this. I feel like we're stuck back in 2022, back when that National Ignition Facility, that laser fusion place out in Lawrence Livermore Laboratory in California, when they shot the pellet of deuterium and tritium with lasers, and they basically claimed that it created more energy than it used, and the world went into a frenzy, and every single news source on planet Earth was reporting that nuclear fusion was going to give us all an abundant cornucopia of energy for forever, with zero emissions and zero negative costs and zero, downsides. You remember that, right? I clearly remember that. And I have a video on that too. So this thorium, there's a lot of technical conversation I could have about it, but the biggest thing is everybody keeps talking about it, and what seems to be actually happening is what China did is they built a test facility that I believe is 2 megawatts thermal. So basically, it's a nuclear reactor that can produce 2 megawatts of heat. Your regular nuclear reactor, like the ones over here at Susquehanna nuclear power plant, each of those reactors is pumping out on the order of 4,000 megawatts of heat. So this thing is puny. It's tiny. It's effectively irrelevant in the world of energy. This is like the first wind turbine, you know. Oh, we have a wind turbine, it makes 10 kilowatts. Really? You know. It actually isn't even producing electricity. It's just producing heat that they're probably just dissipating. According to this description here, China is building a larger 10 megawatt thorium molten salt reactor slated to be operational by 2030, 5 years from now. 10 megawatts, so 10 megawatts in 2030. So, in terms of the actual energy technologies that are being used to expand our power grid here today in 2025, what are they? Is it nuclear power plants? You know, I mean, the last several years we've just heard nothing but good news about how there's a nuclear revival, how it's back in fashion, how tech companies are going nuclear. So last year, the world added a lot of new capacity for generating electricity. And notice that I'm saying electricity, not energy. This is one of those weird things where people are suggesting that this thorium nuclear power plant is going to somehow replace crude oil. And it's funny because crude oil is not something we use to generate much electricity. We don't use really much of any oil product to produce electricity. It's very, very small. 2024, we added around 570 gigawatts, giga, as in billion, watts of capacity based on renewable energy. So that's almost all solar power and wind power. Probably more than half of this, it's not broken down here, but more than half of it is likely to be solar power. China alone installed 250 gigawatts of solar power. So 250 gigawatts is 250,000 megawatts. Our thorium reactor that they're supposed to have up and running by 2030 is what? 10 megawatts. 10 versus 250,000. Why is the news focusing on this thorium and they're not focusing on solar power? Because solar power is the technology that's actually being deployed. Last year, this little gray here, which is like 40 gigawatts, is non-renewable power generating capacity. And out of that 40 gigawatts, like 4 of it is nuclear. Once again, in China, in the form of traditional PWR power plants, pressurized water reactors that use water as a coolant and use uranium-235 or plutonium-239 as a fuel. And water as a moderator and all the technical stuff about it. Everybody's talking about how everybody's going nuclear. Maybe I should just say, yeah, we are going nuclear. But it's nuclear fusion. Natural nuclear fusion. Coming from this fusion reactor that is about 93 million miles away from Earth. All right? That's what we're actually installing. And you can see that in 2023, 2022, 2021, 2020, 2019, 2018, 17, 16. You have to go back to 2012 for non-renewable power generation technology to exceed renewable power generation technology in terms of new capacity additions. Now, of course, the renewable skeptics crowd of the world will basically tell me, well, you gotta be kidding me, the sun don't shine at night, what do you do there? All right, well, there's this magical math called the capacity factor, where basically if we have 550 gigawatts of solar, we can basically say that is a 20% capacity factor, and over the course of a year, that will produce the same amount of electricity as around 100 and some gigawatts of nuclear that can run 90% of the time. So 100 gigawatts of nuclear equivalent versus 4 gigawatts of actual nuclear was deployed in 2025 or 4. Which technology do you think is going to be the star of the show here in this energy transition? It's the one that's the cheapest to build, the fastest to build, the easiest to run, the lowest cost. You don't need any fuel for solar or wind. It's very inexpensive to maintain compared with fossil fuel plants and nuclear plants. Very cheap to build, easy to run. There's really zero risk, especially of solar. There's effectively almost zero risk. Like the worst thing that could happen is you get an electrical fault. There's nothing to explode in terms of steam lines and high pressures, high temperatures. There's no mechanical parts that are going to grenade themselves on you. There's no lube oil system that's going to catch fire. There's no hydrogen cooling, let alone all the nuclear side of things with spent fuel and decay heat and core cooling, and even with these liquid fluoride thorium reactors, you don't have to worry about corrosion destroying anything in the plant. Remember 2022 when France's nuclear power plants were offline for practically a year? Half of them were down for maintenance at any given time because there was corrosion, and that was a water-based system, let alone 900 degrees Celsius molten salt. So the news is talking about nuclear power, thorium, fusion. Oh, this is the thing, right? No, open up the hood, go behind the headlines, and you'll find that's not actually what we're installing. It's not what's going on to the system, right? Global net power capacity additions by, when is this from? That's from 2023. Solar, 428 gigawatts, 118 gigawatts of wind. Nuclear, it doesn't even show up on the graph because it was so small. You can't even see it. Red. Maybe that little red line there that might be part geothermal, part nuclear, part oil and diesel, because they're all kind of bleeding together because they're all so puny. You can kind of get my frustration with the news. Even going back to 2017, 2018, 2019, I mean, look at the red, the yellow, and the blue, and everything else. Natural gas kind of had a year in 2018, but it's really not. Outside the United States, nobody wants to build natural gas-fired power plants because they don't have the resource. It's very expensive to fuel them. Coal. Look at that. With coal, we built more coal than we built nuclear in 2023. Quite fascinating, right? The disconnect between the headlines and what's actually happening. The numbers are like 2 orders of magnitude, like 100x difference in how much nuclear we're building, how much renewables we're building. Solar and wind power produce more electricity around the world than nuclear, and they actually surpass nuclear in the United States. When you add wind and solar together. So, or coal, maybe they surpass coal. 17%, I believe, is the share of wind plus solar. Nuclear might be like 18 or 19%. So it's right this coming year, 2025, it will exceed nuclear. So I don't have a problem with nuclear, other than just, people need to figure out how to deal with all the various lingering technical issues like the engineering problems, dealing with spent fuel. Nobody seems to want to do anything about that at this point in time. There's not a whole lot of action taking place. The stuff's just accumulating. but it works independent of weather. That's the nice thing about it. And it's fairly compact, so you don't really need a whole lot of space to install it. But land isn't really anything that's in scarce supply, so that isn't important to me. But I really just get the disconnect between the headlines and what's actually happening. So that's basically it. It's why we needed to talk about thorium.